Next one is difference amplifier, or we can say like difference amplifier, or we can say subtractor. Okay, as its name suggests, it subtract the two voltage, so it is just like the same. I'll draw the diagram. Again, the terminal with the negative and positive output would be connected to V0 and will provide the feedback resistance connected with the negative terminal. Okay, then we'll provide the resistance for the positive, and like this one is resistance is R1, this one is R3, and here we'll provide a resistance R2. Another terminal of R2 would be grounded. Here we can provide a supply over here, that is V1. Okay, another terminal would be grounded. So this is one of the case for the difference amplifier. Here also R3 is grounded. Okay, now I am drawing the same circuit, but that was in that case. Here in this case V1 is connected with the positive terminal. In that case V2 is connected with the negative terminal. Wait, I'll draw that same diagram. See what is the difference in this. Here you can see V1 is connected over here, but in the next diagram we'll connect V2 over here. This would be grounded. Now you can see the difference. Here we have connected V1 with the positive terminal. Here we have connected voltage V2 with the negative terminal. Okay, so we have to make the both the things, or we okay. So now again you have to apply. So output of this would be V01 because we have connected V1 voltage here. Output of this would be V02 because we have connected V2 terminal here. Okay, so can we get the V01 value over here? V01 value is how much? Again, this is a voltage Vx, so it would be Vx. As you can see, it is similar to the inverting terminal or the non-inverting terminal. Inverting amplifier or the non-inverting amplifier? Similar to non-inverting. And what was the output for the non-inverting? That is 1 plus Rf over R2. In this R2 is there. Similarly, we can write it down for V02. V02, it is connecting to negative terminal or the for the negative terminal we have to see the output for the inverting amplifier or for the non-inverting amplifier. Inverting, for inverting what would be the output? Minus V2 multiplied by Rf over R2. Okay, so this is the difference. We have connected over the negative here, so output is minus Rf over R2. Okay, and in this we have connected with the positive terminal Vx, so we have to take it for the non-inverting amplifier, and in non-inverting amplifier output is 1 plus Rf over R2. Got it? Any doubt? So we need the final V0. V0 would be equal to V01 plus V02. Ultimately we have to add it only. Okay, we can't subtract. So it would be how much? Tell me. Vx multiplied by 1 plus Rf over R2, and then minus V2 Rf over R2. Okay, any doubt up to here? I just simply put down the values for V0, V01 plus V02. Got it? So but now we have to calculate the value of Vx. Can you tell me what is the value of Vx over here? Yeah, in non in, no, we don't we have to use it voltage division rule. Vx would be equal to how much voltage we have applied? V1 multiplied by the, in which resistance we need to calculate voltage, divided by the sum of resistance. Okay, so can we put down all the values over here, Vx and all? So the final conclusion would be V0 would be V01 plus V02, right? V01 is how much? Vx into 1 plus Rf by R2. V02 is minus V2 Rf over R2, right? Vx value we just calculated by using voltage division rule. So we can put it over here. Vx is how much? V1 into R3 divided by R1 plus R3 multiplied by the same thing, 1 plus Rf by R2 minus V2 Rf by R2, right? If I'll consider R1 is equal to R2 is equal to Rf, like see the diagram, if I'll consider R1, R2, Rf, all three resistors are same. Okay, then what we got the final value? V0 would be equal to V1 minus V2. That is exactly the difference of the two voltages.